Hi, welcome to JEE Chemistry Tutor. In this class, we will talk about atoms. In this chapter, we will cover these subtopics. The modern theories on atomic structure starts from the dual nature of matter. But before going into the modern theories on atomic structure, we will look on the history of atomic structure and how different theories on atomic structure appeared and how one after one old theories has been discarded by the new one. The concept of atom is not a new concept. The word atom came from a Greek word atomium, which means indivisible. Greek philosophers believed that all matter consisted of some small indivisible particle, and these are called atoms. Though the idea was dormant for a long time, in the beginning of the 19th century, British scientist John Dalton first proposed a theory on atomic structure. I think we all heard about the Dalton's atomic theory on 10th standard. Let's see what was the postulates of Dalton's atomic theory. The first postulate was regarding the definition of an atom. What was the definition of atom according to Dalton's atomic theory? All matter consisted of some small indivisible particle that can be subdivided further, and these are called atoms. And atoms of different element differ from each other. Like atoms of element A won't be the same with atoms of element B. But the atoms of same element will be identical in nature. And the atoms of different element will combine in a ratio to form a compound. So this is the postulates of Dalton's atomic theory. Though it can explain some of the facts like law of mass conservation and law of constant composition, but it has certain drawbacks also. Let's see what are the drawbacks of Dalton's atomic theory. It says that atoms of different elements differ from each other. But according to this theory, atoms are indivisible particles. So how atoms of different elements differ from each other is not clearly understood from this theory. And the second thing is that how atoms of different elements combine to form a new compound is not clearly understood from this theory. And so this is the first theory on atomic structure. Later, in the end of the 19th century, scientists has discovered many subatomic particles: electron, proton, neutron. So after the discovery of the subatomic particle, atom is no longer an indivisible particle. So after the discovery of the subatomic particle, the Dalton's atomic theory has been discarded. The subatomic particle electron was discovered in cathode ray experiment, and it has found that it is negatively charged, and the charge of an electron is determined by Mulliken in his famous Weyl-Roth experiment, and it has found that this charge is minus 1.602 into 10 to the power minus 19 coulomb. And the mass of electron was determined by J.J. Thomson, and it has found that it is 9.1 into 10 to the power minus 31 kg. So it is the very light particle. And the proton was discovered in anode ray experiment by Goldstein. And it has found that it is positively charged, and the charge of a proton is equal to the charge of an electron. But it is a little heavier than electron. Its mass is 1.673 into 10 to the power minus 27 kg. And neutron was discovered later by James Chadwick in 1932. The later discovery of neutron is due to its neutral nature. And it has found that it is the heaviest subatomic particle among electron, proton and neutron. Its mass is 1.675 into 10 to the power minus 27 kg. So the discovery of subatomic particle has discarded the Dalton's atomic theory. After the discovery of subatomic particle, many questions came. One of the major questions was how atom is maintaining its electroneutrality, though it contains the negatively charged electron and the positively charged proton. To answer these questions, in 1898, scientist J. Thomson first proposed a detailed model on atomic structure, which is known as Thomson's palm pudding model. What are the postulates of this model? He proposed that an atom possesses a spherical shape in which the positive charge is uniformly distributed and the negatively charged electrons are embedded in this spherical shape in such a way so that it can attain a stable electrostatic interaction. And another assumption of this model was the mass of an atom is uniformly distributed. So the postulates of Thomson palm pudding model was charge is uniformly distributed, and also the mass. So by assuming that the negatively charged electrons are embedded in the positively charged proton, it can explain the electroneutrality principle. After few years, in 1911, British physicist Rutherford was doing one experiment on alpha particles scattering. What was that alpha particle scattering experiment and how it is related to atomic structure, we will see. The stream of alpha particle is coming from a radioactive source, and then it is passed through a lead plate and then in hit a very thin gold foil. A circular fluorescent screen coated with zinc sulfide was placed around this gold foil to detect the deflection of the alpha particle. Okay. What was the major result of this experiment? What are the observation of this experiment? Let's see. It was observed that most of the alpha particle, around 99% alpha particle, remains undeflected. a small fraction of the alpha particle was deflected by a small angle. So a small fraction of the alpha particle was showing a small angle deflection. And very few alpha particle are bouncing back. A very few alpha particle bounced back. Now the results of this alpha particle scattering experiment was quite unexpected, since it could not be explained from Thomson's palm pudding model. Now, according to Thomson's palm pudding model, the mass and charge of an atom is uniformly distributed. Now, the alpha particle have enough energy to cross such uniform distribution of mass. And while passing through it, it will experience a very weak electric field, and due to this there will be very small deflection of the alpha particle. But in this case, in the alpha particle scattering experiment, most of the particles remain undeflected. So Rutherford concluded that since most of the alpha particle remains undeflected, most of the space inside an atom is empty. So what was the first conclusion? First conclusion was that most of the space empty. And since very few alpha particles are bouncing back, so what might be the reason that those alpha particles are bouncing back? Alpha particles are positively charged particles. So Rutherford concluded that these are bouncing back because they are facing enormous repulsion. And since it is facing, and so the positive charge is not uniformly distributed. Rather than the uniform distribution, the positive charge is concentrated. The positive charge are the concentrated. And since very few alpha particles are bouncing back, the volume where the positive charge are concentrated is very small compared to the total volume of an atom. So Thomson's palm pudding model was not able to explain Rutherford alpha particle scattering experiment. The results of Rutherford's alpha particle scattering experiment has discarded the Thomson's palm pudding model. So Rutherford then proposed a nuclear model of an atom. However, the major hypothesis of his model was that an atom has two parts. First part where the positive charges are concentrated, that is called nucleus. And second, the negatively charged electrons are revolving around the nucleus, and this portion is called extranuclear part. The centrifugal force for the circular motion of the electron, is provided due to the positive charge of the nucleus. And the force of attraction between the nucleus and the electron is balanced by this force. So this is balance. The second postulate is balance of force. And the third postulate was that the number of negative charge in the extranuclear part is equal to the positive charge inside the nucleus. In this way, it is maintaining the electroneutrality. Now, if we look at the Rutherford's atomic model, we can see there is a clear similarity of Rutherford's atomic model with solar system. Charged electrons are revolving around the nucleus in the same way. In the solar system, the planets are revolves around the sun. So there is certain similarity of Rutherford's atomic model with the solar system. That's why sometimes this Rutherford's atomic model is called planetary model of an atom. Though it has some degree of similarities with the solar system, it has certain difference also. What is the major difference? In solar systems, the planets are uncharged. The planets are uncharged. But in an atom, the electrons which revolves around the nucleus are charged particles. This is the major difference between an atom and the solar system. Now, it is important to mention here that before Rutherford's atomic model, Rutherford gives his atomic model in 1911, and before that in 1860, James Maxwell gives his electromagnetic theory. What is it and how it is related to Rutherford's atomic model? According to Maxwell's electromagnetic theory, when an electrical charged particle moves under acceleration, the electric and magnetic fields will be produced and transmitted, and these are transmitted in the form of wave, and these are called electromagnetic wave. Now come to Rutherford's atomic model. In Rutherford's atomic model, the negatively charged particles are revolving around the nucleus. So, while it is completing its circular motion, it will generate the electromagnetic wave. And this the energy of the electromagnetic wave will come from the circular motion. So what will happen due to this? The path in which the electrons are revolving around the nucleus will start shrinking. And it can be shown by calculation that within 10 to the power minus 8 seconds, it will spiral to the nucleus. So the stability of the atom will be hampered. But this is one of the major drawbacks of Rutherford's atomic model. The drawbacks is the stability of an atom. Rutherford's atomic model is not able to explain the stability of an atom. Secondly, though Rutherford gave the nuclear model of an atom, it doesn't talk about the distribution of electron in the extranuclear part. How the electrons are distributed around the nucleus and what are the energies of this electron. It didn't talk about these things. It remains silent on the energy of electron. Another thing is that it was not able to explain the line spectrum of hydrogen atom. We will discuss about the spectrum of hydrogen atom in the next class. So before that, we are talking about the drawbacks of Rutherford's atomic model. After that, we will move to atomic spectra of hydrogen. According to Maxwell's theory, the electrons are moving around the nucleus and it is a charged particle, so it will emit energy, and the energy emission will be continuous. So the atomic spectra of hydrogen, we should get a continuous or band spectra. So if Rutherford's atomic model is true, then we should get a continuous or band spectrum for hydrogen atom. But what we are getting in the hydrogen atom atomic spectra, some lines with discrete energy. And this cannot be explained by Rutherford's atomic model. So the drawbacks of the Rutherford atomic model demands new theory to explain the structure of an atom. In the next class, we will see how new theories have overcome the drawbacks of Rutherford's model. Till then, bye. We will see you in the next class. If you like our videos, please share it.